Okay, what we're looking at now is the derivative function. Okay, so the derivative function is a function that can be used to determine the instantaneous slope of a curve for any value of x. So here, if we have the function y equals x squared take x, okay, we can see that the slope of this function is definitely going to be different at A compared to point B and compared to point C. They're all going to be different slopes. So what we can do then is determine a slope function. So here's how we do it using first limits. Basically, all you're doing differently from before is we're saying we've got our first point, and rather than it being for a particular value of x, we're just going to use the variable x. Okay? So when we use x, what's y equal to? Y is equal to x squared take x, of course. And again, we use the point x plus h. Okay? So we're pretending we've zoomed in on this function. Okay, it could be any point along the curve, so it could be any variable x. Okay, so we've got the point x and x plus h, which means our y coordinate then is going to be x plus h squared take away x plus h. Okay, again, exactly the same process. We're doing y2 take y1 on x2 take x1. Okay, so our slope is going to be, and again I'll put it up here, where as h is approaching 0. Okay, so h is a very small number. Alright, the distance between these 2 points is infinitely small. They're very close together, but we can use it to approximate the slope of the line. So the slope is going to be equal to y2, which is x plus h squared, take away x plus h. Okay, so that's our y2, take away y1. Okay, now I'm going to put this in brackets to show that this is y2, and then our y1 is just going to be x squared take x. Okay, because that minus is applying to everything inside the bracket, so that's where it can get a little bit tricky. Okay, and all that is over x2, which is x plus h, take x1, which is just x. Okay, so we're going to expand this out. Here we have x take x, that can cancel, and let's expand these brackets here. So in the first bracket we're going to have x squared plus 2xh plus h squared, and that's going to be take away x and take away h. Okay, and then we're going to have take away x squared take x, so it's going to be take away x squared plus x. Okay, minus minus becomes a positive. Alright, and that's all over h. Alright, so let's expand this out now. Alright, what do we have? We're going to have, collect our common factors. We've got, okay, so here we can see we've got x squared, and we're taking away x squared, so they can, both of those can cancel. We have 2xh, okay, and this one here can cancel as well, minus x and plus x, so that cancels. So what we have at the top then is 2xh plus h squared take h divided by h. Okay, so common factor for the top again is going to be h, so we can pull it out the bracket. We're going to have 2x plus h take 1, and that's going to be over, again pull h out from the denominator as well. Okay, and those two can cancel, so what we have is 2x plus 1, or 2x take 1 plus h. But remember, h approaches 0, so therefore the slope function equals 2x take 1. Okay, so let me tell you what this part means, because this is a fairly significant answer here. Okay, so at any point along this curve, okay, let's say we want to know the slope when x is 2, okay, we just have to put it into this function. So the slope at x equals 2 is going to be 2 times 2 take 1. 4 take 1 is 3. Okay, so the slope at x is 2 is 3. Alright, the slope at x equals minus 3. So we're putting minus 3 into the function, so we have 2 times minus 3 take 1. It's going to be minus 6 take 1, which is going to be minus 7. So when x is equal to minus 3, the slope is minus 7. So the significance of this answer then is we can find the slope of this function for any value of x using our derivative function here. We have derived a function from our initial function that can be used to calculate the slope at any point.